Yes, good afternoon to the students, all triple second year students. Right. So today we do start with our regular electrical circuit analysis subject. So very first thing, any one student, you please confirm me whether the voice is audible or not. Then we start the process.
Yes, sir, you are audible.
Okay, right.
Yes, sir.
Thank you. Now, so what we are going to take, what is the topic we take here as per our syllabus? We are going to take the time response of RL circuit, RL series circuit first. So I want to present that particular topic in a practical manner so that you can even visualize what exactly the difference between electronic signal and electric current. So first, let us start with this one. So any guesses, anyone, what is the waveform you are able to see on the screen? What is the name of that particular waveform? Anyone student? I request all students to mute yourself. The waveform which is available on the screen, let me maximize this one. Right. Now you can see this is what the signal we deal with the engineering. So electrical engineers, we always think about the conductors, magnetic field and different machines, but here we should also work with the how to create electromagnetic wave. On the screen you are able to see the electromagnetic wave, which is a combination of electric field and magnetic field. So anywhere if my voice is breaking down or any disturbance, you can be free to ask. Okay, what are?
No, sir.
Right. So what specialty we can do? What is a new approach we can design in the engineering is developing a signal, electromagnetic signal, sending that signal through the air without any wires and to turn on one particular load. So what is a new invention we are supposed to do with respect to our second year electrical circuit analysis subject? We should know how to create the electromagnetic signal or electromagnetic wave and how to transfer that electromagnetic wave through the air and how to run one particular motor without using direct plug-in connection. So what is this electromagnetic wave first? So why it is called wave? A wave is an energy which travels from one place to another place. When it travels, it carries the energy. Okay. So what is electromagnetic wave? Electromagnetic wave is a combination of electric field and magnetic field, which are always perpendicular to each other. So you can see the magnetic field, which is mentioned in red color, is perpendicular to the electric field. Naturally, so I will show you how to generate this electric and magnetic fields. So if you want to send certain signals, or if you want to send the wireless power from one place to another place, first you must be in a position to generate the electric field as well as the magnetic field. So one simple question, what is the difference between electric energy and electric field? If the energy is not constant at one place and if that energy is distributed everywhere, then that energy is called the field. So in all the textbooks we see electric field, magnetic field. Why they are not mentioning electric energy and magnetic energy? So if the energy is not constant at one place and if that energy is distributed everywhere equally, then that energy can be represented as the field. So what is this electric and magnetic fields? Why they are perpendicular to each other, we'll discover. So first I am going to give the definition of electromagnetic wave. So what is the use? Our cell phones. All the students, please mute yourself. Okay, I request. Right. So in electrical circuit analysis, we are supposed to develop certain mathematical equations. So how to develop that mathematical equations? First, we must know the concept here. So let us take one particular concept where without using the copper wires, I want to turn on one particular motor. Okay, so motor is connected to the supply. that concept we are not using. With the help of electromagnetic signal or electromagnetic wave, I want to turn on one particular bulb or I want to turn on one particular motor. So how to explain this process with mathematical equations is our topic, which is time response of RL circuit or RLC circuit. So why that circuit is created also we'll discuss in today's class. So first, what is electromagnetic wave? Electromagnetic wave is the combination of electric field and magnetic field. Both these fields are perpendicular to each other and they always travel from one place to another place. When they travel, they carry the energy from one region to another region. So this definition in detail we'll discuss. So in your lifetime, you should never forget what is the definition of electromagnetic wave. Electromagnetic wave is the combination of electric field and magnetic field which are perpendicular to each other, which are not constant at one place, which travels through the air at speed equal to speed of light. What is the speed of light? 3 into 10 power 8 meters per second. Okay, right. When they travel at speed equal to speed of light, they transfer the energy. With that energy, you can turn on the bulb or you can turn on the motor. So now I am going to move to the next slide where we discuss what is the exact real concept of electromagnetic wave. Just a minute. Right. So now imagine a conductor is given to you. We all are electrical engineers. So first, when we see a conductor, we say, okay, it is a conductor. When current flows through the conductor, it conducts. But now, if any electrical engineer observes one particular conductor, we should see with respect to the electric field. So this conductor, if somebody asks you what you can experience inside this conductor naturally contains number of positive and negative charges. So from where the origin of electrical engineering starts, if a conductor is given to you, you must visualize that conductor as this conductor is a combination of number of positive and negative charges. Complete. So now let us see practically. Yes. So one conductor is given to you. You can see every conductor present in this world, the copper, aluminum, they are associated, they contain number of positive and negative charges. So you can see always electric lines of force. Always electric lines of force, they move away from the positive charge and they reach towards the negative charge. So what is the internal structure of the conductor? Means every conductor naturally, without giving any supply, they are having the combination of number of positive and negative charges. These positive and negative charges create electric field or electric energy. Since it is not constant at one place, we call it as the electric field. I hope this point is clear. So from today onwards, when you in future also, when you do any practical project also, once you see a copper wire or copper conductor, this conductor is a combination of number of positive and negative charges which contains the electric flux lines. You might have studied magnetic flux, but we are also having the electric flux, electric field lines. So inside the conductor, we are having number of positive and negative charges. So always the electric flux lines or electric field lines move away from the positive charge and they move towards the negative charge. Okay, this is what without passing the current through the conductor. So whenever we see a conductor, this entire conductor containing number of positive charges and number of negative charges. Right. So this is what the representation first. Now, let us say, so we say every conductor is associated with electric field. This is the objective type question even in the competitive examination. Without passing the current, which field is associated with the conductor? Electric field. So every conductor naturally contains number of positive charges, number of negative charges, and due to the combination of positive and negative charges, electric field is created. So from today onwards, wherever you see the conductor, so you should never say it is just a copper conductor. This conductor is associated, or it contains the combination of number of positive and negative charges with electric field. So every conductor contains the electric field, which we cannot see with our eyes, but we can measure with the devices. So now, next one. Let us say I am passing the current through the conductor now. So whenever current flows through the conductor, we already know, everyone know, magnetic field is created across the conductor naturally. That is a basic behavior. That's why we are having electromagnetic induction. Why the name induction? Why not generation? Because already current is flowing. The new energy is created because of this input energy. That's why the word is induction, and it is purely magnetic in nature. So what is the next basic thing? So first basic origin is, whenever a conductor is given to you, we assume that electric field is associated, or electric field is completely developed across this conductor. Now whenever current flows through the conductor, magnetic field is also created. So a current carrying conductor contains electric field and magnetic field. Show me that electric field and magnetic field. This is the first slide what I have shown the animation just now. I hope now everybody is clear. This explanation is clear. Electromagnetic wave. What is this electromagnetic wave? What it will do? Electromagnetic wave is a combination of electric field and magnetic field, which can travel through the air at speed equal to speed of light, and it carries the energy. With the help of that energy, any load can be turned on, whether it is a bulb or whether it is a motor. So I hope the new way of explaining the electrical engineering is with this definition. You can ask, sir, what I can do with this electric and magnetic field? Okay, conductor is there. Conductor contains electric field. We pass the current through the conductor, magnetic field is created. So with the combination of electric and magnetic.
Sir, excuse me, sir. Your voice is getting stuck.
Voice is getting stuck. 1 second.
Yes.
1 second. Yeah. I think certain network issue is going on from today morning here. Please, anyone, just remind me whenever the voice is breaking down. That's why I was asking. Now it is okay, somewhat. Anyone, student, please unmute and tell me. Now the voice is okay, audible?
Yes, sir.
Okay, sir.
Okay, great. Okay, we'll see here. We'll see, because okay, but the day it will be there. Now, so what is the definition of electromagnetic wave? Is our first basic topic today. Electromagnetic wave is the combination of electric field and magnetic field, which travels at speed equal to speed of light. When they travel, they carry the energy from one place to another place. With that energy, any load can be turned on. So that's why the very first slide what we have taken is electromagnetic wave. So how this electromagnetic wave is generated? It is every conductor contains naturally electric field. This is what the visualization. Whenever current flows through the conductor, magnetic field is created. Now you must remember one particular assumption. In all our machines, generator and motor, all the engineers have neglected the electric field. That's why we study whenever current flows through the armature winding or field winding, magnetic field is created, right? So this assumption is removed. But now for our subject, we should imagine every conductor contains the electric field. Whenever current flows through the conductor, magnetic field is created. Therefore, everywhere we are able to see the combination of electric and magnetic field. So now with this introduction, now I am going to start this circuit here. So now you might have understood, sir, why we are having the inductor in capacitor in this circuit, resistor, of course the opposition to the current. So what is the new definition of resistor? Why I have to place the resistor in the circuit? If resistor is not placed, large current can flow through the circuit, the circuit might get damaged. So what we have to do, resistor limits the starting current, or resistor reduces the strength of the current and passes the required or safe current. So everyone will say resistor opposes the current. Actually, resistance opposes the current. But what is the new way of explanation? Resistor placed in a circuit will decrease the strength of the current and passes the safe current to the circuit. So why you are placing the inductor? So without creating magnetic field, we cannot transfer the energy. So we must place the inductor. And capacitor, electric field is associated with the every copper wire. So what is the equivalent circuit of this copper wire, anyone? What is the equivalent circuit? The equivalent circuit of this copper wire is, it has got resistance, it has got the magnetic field, even it has got the electric field. Therefore, what we do, what is the equivalent circuit? We are having the combination of resistor, inductor and capacitor. I hope this is understood to everyone. Any one student, once again, please confirm it is okay, this particular point, as you people are the new students. Okay. So why we are placing resistor, inductor and capacitor in the circuit? We got different explanations. So what is a basic explanation why we have to study RLC circuit? Means every conductor contains resistance, inductor as well as the capacitor. That is we see the presence of opposition, magnetic field and the electric field. So the basic behavior of the conductor is represented in the equivalent circuit as resistor, inductor and capacitor, RLC series circuit. Okay. So now, is it okay? Any one student?
Yes, sir.
Okay, sir.
Okay, right. So that's why in electrical circuit analysis, the subject name is electrical circuit analysis. So analysis means finding the behavior of the circuit. I want to study the behavior of the circuit with the help of AC supply and DC supply. So how to study the behavior is our subject. Okay, so now we know why we are having the inductor, capacitor in a basic form representing any conductor. Okay, then what next? What next we have to do? As an engineer, we have to explain the behavior using mathematical equations. You can see one equation here. So I want to explain the behavior. I cannot explain in theoretical language. So our engineer's language is diagrammatic language and mathematical modeling here. What do you mean by the word modeling? Means making the mathematical representation of the system. Okay. So first circuit you must develop according to the physical behavior, and then you must write the equation. So what is a KVL? Everybody know, algebraic sum of voltage sources equal to voltage drops in a closed mesh in a simple language. That means if for this, let us see the second circuit. So here I can use the switch, I can turn on and turn off this circuit. So let us say the switch is closed here. So what is the supply? I'm taking DC supply. First we do the circuits with DC supply and then we move for the AC supply. So RLC we are having. Okay, everybody know this.
Sir,
Yeah. Voice is breaking down
it's
again.
getting stuck. Yes, sir.
Second, 1 second. Okay, we'll check. Okay, for the day you check this one. Whenever it is breaking down, please I will go slow over there. Okay, right. Cool. We'll rectify this one. The technical issue, I think, the internet one. Right. So now, so this circuit, all of you are able to see the mathematical equation. So when you apply the KVL for the second circuit, what is the KVL equation? Voltage source V. Okay. So how many voltage sources are there? Only one. So voltage source V is equal to, now what is the voltage drop across the resistor? R into I of t. As the current is changing with respect to time, we have taken V is equal to R into I of t. And what is the voltage formula across the inductor? I hope you have done the polytechnic. L into di by dt, because for the inductor it is always rate of change of current, L into di by dt. And what is the for the capacitor? 1 by c integral I of t dt. We will write it later on. So Vc of t. I hope this explanation is clear here up to this point. So when for any circuit, what is a basic mathematical equation? The mathematical equation is developed in the form of differential equation approach. The mathematical equation is developed in the form of differential equation approach. So V is equal to R into I of t plus L into di by dt plus Vc of t. But now the next step, okay, so the question is, this topic is explain the time response of RL circuit or RLC circuit. So first we have taken this circuit here. So this equation, the explanation of this circuit by writing the differential equation, we say that it is time domain process. Which domain, anyone? Time domain. Domain is the basic. So every equation is represented with respect to time domain. But if I want to explain clearly, what I have to do, I have to convert this time domain to frequency domain. So let us say you are sending the signals into this space from one planet to another planet. So if somebody asks you how to explain the behavior of that signal, means you must explain in frequency domain. What is that frequency domain is our topic. So any electrical circuit, by applying KVL, we obtain the expression in differential form, as you are seeing on this one. Now the differential equation must be converted into frequency domain using, I hope you have done in diploma, Laplace transform. Have you studied in diploma?
Excuse me, sir.
Yeah.
Sir, we are not understanding, sir. It's getting full stuck.
Voice is getting stuck. Okay, let me do one
Yes,
thing.
sir.
Let me do one thing. Okay, give me a minute. Be online.
Okay, sir.
So all the students, first you check for 5 minutes. If it is, if the network is down and if you are not able to listen clearly, we'll schedule for the tomorrow. There is no issues. Only for the day we have the network issue here right now. Right. So first 5 minutes you listen. If at all any voice breaking down concept is there, you please intimate me. We'll go for the tomorrow. Okay. So I'll do one thing. First, I hope up to this point it was clear. So why we are supposed to place the capacitor and inductor. Okay. So now we got this circuit. For this circuit, in what way we represent in our electrical circuit analysis concept. If a circuit is given to you, so we must apply KVL, the very first step. So KVL voltage equal to, or source voltage equal to R into I of t plus voltage across the inductor plus voltage across the capacitor. So this equation is having the variables are changing with respect to time. So imagine you are sending certain signals or you are communicating from one cell phone to another cell phone. So if somebody asks you how much energy is transferred from one place to another place, you cannot explain using this differential equation. Differential equations technique is very old method. We require the latest advanced time consuming methods within short period of time. So what we do, very first step, we apply KVL to the circuit and then we convert this di by dt or R into I of t to the frequency domain, S domain. Okay. So what we do, which network we are having, which method is we are having to convert time domain to frequency domain. So now voice is any breaking concept is there? Once again, you listen for 1 more minute and please confirm me. Okay. The Laplace transform is the tool which converts the time domain quantities to frequency domain. Okay. So all the differential equations are converted into frequency domain approach. So how to do that one, we'll see. So first, for any given circuit, apply the KVL and then apply the Laplace transform, the second statement. Apply the Laplace transform on differential equation, and then Laplace transform converts time domain to frequency domain. Sir, what is this word frequency domain? Everything we'll see right now. And then apply inverse Laplace to get the initial behavior of the circuit. So I explain here, any circuit behavior cannot be explained using differential equation approach. That circuit behavior should be explained by converting the differential equation to frequency domain. So we must convert the mathematical equations from time domain to frequency domain. The advantage is very short period of time we can get the exact results. Okay. So now this is the circuit. So we see in what way we convert the every differential equation to frequency domain. So as it is a first class, I hope in diploma you have done. So I will revise certain formulas what are necessary for us. Laplace transform of time I of t is I of s. Laplace transform of derivative is L into S into I of s. Okay. So Laplace transform is the tool which converts the time domain quantities to frequency domain. Frequency domain we represent by S, complex operator. So Laplace transform of e power minus at is 1 by s plus a. Laplace transform of integration is I of s by s. It is I of s by s, and Laplace transform of 1 is 1 by s. So now let me share the first circuit what we are supposed to take in the time response analysis. Right. I hope all of you are able to see the new slide which I am sharing. Okay. So first we'll go with the RC circuit. Right. All students just see here. And this is what you are supposed to get in the examination. Explain the response of simple RC circuit. Okay. Now all of you, the voice is clear. Anyone confirm, please?
Yes, sir.
Yes, sir.
Okay, right. Okay. So what we have to do? So examination, they will ask you explain the step response of an RC circuit. So you must draw the circuit here as it is. So first we are having the response study with DC supply and the switch on and off condition. Right. So as it is the introduction class, we take with the basic approach. So why this capacitor and resistors are created? Because if you take the example of your smartphone, from the smartphone you are generating the electromagnetic wave, you are sending that electromagnetic wave through the space. So it is possible with the help of inductors, capacitors present in the circuit. So huge smartphone circuit we cannot study right now directly. So first we have to study the RL circuit, RC circuit, RLC, and then parallel combination. I hope you understood. So any smartphone or laptop or any electronic device is a combination of number of inductors and capacitors which generate the electric field and magnetic field. So we are supposed to study first the basic circuits. So how to explain the behavior of this circuit? So very first approach is what? Apply KVL. Let us say the voltage source is V. So what is the KVL statement, all of you? I hope everybody is perfect. Voltage sources, algebraic sum of voltage sources equal to voltage drops. So E is the voltage applied to the circuit. E is equal to, what is a resistor? R into I of t. This all after switch is closed here, neglecting initial conditions. And what is the voltage across the capacitor formula, which you have studied from our basic lower classes? 1 by C integral I of t dt. Because across the capacitor, voltage will develop, the positive charges and negative charges. So voltage across the capacitor is 1 by C integral I of t dt. So recording of this class will be sent to you. No need to worry, whatever we are discussing. But online you have to listen. Right. Now, you just see, make a note of this for explanation also what we are doing right now. So this is the time domain equation for this circuit. Okay, you might have done in the Polytechnic also, but we are supposed to extend with the problems. So first classes we are going to take the derivation. You will get definitely explain the time response of RC circuit or RL circuit. So equation we have applied the KVL. E is equal to R into I of t plus 1 by C integral I of t dt. Okay, is it clear up to this one? All the students, as it is a mathematical part, I will be asking. Okay.
Yes, sir.
Yes, sir.
Okay, right. Anywhere, if you are finding difficulty or not understanding, you can be free to ask. Okay, no hesitations. Now, as it is the voltage is constant, we should write here E into 1. Okay, constant voltage. So what is the Laplace transform of 1? Laplace transform of 1 is 1 by S in frequency domain. So therefore we are getting here E by S. Laplace transform of 1 is 1 by S, E by S. Now what is the Laplace transform of I of t? Resistor will not store the energy. Therefore resistor is represented as it is. Okay. Laplace transform of I of t is nothing but I of S, because we are converting from time domain to frequency domain. So the behavior of this circuit can only be explained in which domain or which basic language, technical language. It is the frequency domain, S domain. So what is the Laplace transform of integration? As I mentioned, I of t, Laplace transform of integration is I of S by S. So 1 by C is represented as it is. So 1 by C integration of I of S by S is the expression. This is applying Laplace transform. So first we must write the differential equation and then apply the Laplace transform to the differential equation. Okay. Now, so I of S you can take common. So R plus 1 by CS you are going to get E by CS. But every expression, now we require the current. How much energy is transferred from one place to another place, or what is the current flowing through the circuit? So I is equal to V by R. But here we say I of S is taken common. E by S by R plus 1 by CS you are going to get. But every expression we must have S plus A and S plus B, all of you. S plus A and S plus B. Therefore here we take 1 by CS we got. S plus A we must have. So what we do here, we take, if you take the LCM, RCS plus 1 by CS, and we are going to take this RC, divide the expression numerator and denominator by RC. Okay. So here what we are having, I of S into R plus 1 by CS. Do the LCM. What is LCM now? RCS plus 1 by RCS. Okay. So SS get cancelled. So SS value will be there in the denominator. RCS plus 1 by CS. Here also SS get cancelled. And take the RC common. If you take RC common, what is the denominator you are going to get? S plus 1 by RC. Now apply inverse Laplace. Because answer we cannot show in the frequency domain. We must convert the frequency domain to time domain, because the results we require in time domain. So applying inverse Laplace transform to I of S is I of t, here you can see, and this E by R is constant. So 1 by S plus A, 1 by RC is nothing but S plus A. Just now I have showed the formula. 1 by S plus A is nothing but E power minus AT. E power minus AT. So the very first unit we got the Laplace transform techniques, how we are applying to the circuit. But as an engineer, you must know what we are supposed to do. So Laplace transform converts time domain to frequency domain. Again, the result should be shown in time domain. Therefore, we convert the frequency domain to time domain. What is the basic difference between time domain and frequency domain or S domain? Frequency domain approach for complicated circuits becomes easier within short period of time. So I repeat this derivation once again. When we apply KVL to this circuit, we get voltage source E is equal to R into I of t plus 1 by C integral I of t dt. Laplace transform of E into 1, it is a constant voltage, E by S, R into I of S plus 1 by C. Laplace transform of integration is I of S by S. I of S, as we require the current flowing through the circuit, I of S is equal to, take the I of S common, R plus 1 by CS. Okay, right. So I of S, if it is taken common here, you can bring this one to the denominator. So what we do, take the LCM here, RCS plus 1 by, what is the denominator? CS. So what is going to happen? SS get cancelled. This is domain, but numerator is RCS plus 1. So what we are going to get? E by RCS plus 1 here, right hand side. So dividing the expression by RC, numerator and denominator. So when you divide, what's going to happen? The CC get cancelled, E by R divided by S plus 1 by RC. So as it is online, I'm just showing this particular derivation. Apply inverse Laplace. Inverse Laplace transform of I of S is I of t and E by R is constant. 1 by S plus A is nothing but E power minus AT. In diploma mathematics, you might have studied Laplace transform of E power minus AT is 1 by S plus A. So L inverse of 1 by S plus A is E power minus. So first I'll stop here for the class. First, now you can generate any question. Last 1.5 minutes is there. So within 2 or 3 classes, we are going to run with the different tools where 1 hour session will be there without any lagging. So I request all the students. So any question is there regarding for today's class? Of course, certain network issue was there. Now, as it is first class, I want to take with the basic circuit. Now, the next one we can do with the RL circuit. So in practical cell phone, we are having the combination of RL and RC. Those complicated circuits, how to develop the equation is what we study in this subject. Okay, so first basic circuits are RL and RC. Now go ahead. I'm giving the time. Last 1 minute we are having. So all the students, any general question, any question is there? Just like you have asked in last class. Now also you can ask. Yes, anyone, unmute and you can ask. Yes, last 1 minute we are giving for the doubts clarification. Derivation is okay. Yes, all the students, anyone